let's go.
Okay. Our project is gaming control for amputees. Members of our group were Alyssa Huang, Bin Min Nguyen, Shiv Gohil, and Katerina Baxter. So the motivation for our project is making a way for amputees to be able to game, since obviously without two hands it can get a little tricky with the keys that you need to press. Upper limb amputees, there are studies that show that gaming can improve motivation and outcome of physical training, where they have to train their arm to precisely control EMGs for prosthetics. There's also mental health and therapeutic benefits of gaming for people who have gone through traumatic injuries, since 80% of amputations are due to a traumatic injury. There are, as of 2005, 1.6 million amputations, and that's projected to double by 2050 due to a variety of factors like diabetes and other diseases. The device that we created is designed for transradial upper limb amputees, which means that they have been amputated below the elbow. And our sensors use the bicep muscle to control different keys on a keyboard. So we have an accelerometer here to detect how your arm is moving, an EMG sensor here and here in this picture, which determines if you're flexing your muscle or not, and we use that to control when to read a keystroke. We also have the ESP32, which is used for wireless control to a computer. And this sensor obviously is designed to use the bicep muscle, but could be adapted for a different muscle depending on how someone's arm is amputated.
Alright, so one of our main sensors on here is the EMG itself. Basically, the EMG will read activities in the muscle, and then this module, the MyoAware version 1 EMG sensor, will then output the activity, which you can see the graphic on the right. We use that activity to decide if the muscle is flexed or not by using a cutoff, upper and lower cutoff, and using hysteresis to keep it on.
So to detect motion, we used a simple 3-axis accelerometer. It just measured acceleration to X, Y, and Z axis. And so when the muscle tenses up, we use that as a reference point, and then we move the arm, which tells us a direction in which to make the key press.
We also use two ESP32s to communicate from our device to the computer, which is receiving the keystroke. So essentially, every time the accelerometer and the EMG sensor determines that there should be a keystroke, it will send a signal to our ESP32 on the arm, which will send a byte wirelessly through Wi-Fi to another ESP32 here, which is connected to our computer. And that is connected to another microcontroller that will allow, that will read data from the ESP32 and then tell the computer which keys to press based on that. So we have a lot of wireless systems going on here. And here we will have a demo. So here you can see Binmin is using his arm motions to control the game 2048 on the screen. If you look closely, the movements of his arms will match the game movements on the laptop screen. So when he goes down, you'll see that the 2048 game goes down. When he goes right, you'll see that it goes right, so on and so forth. Thank you.